So this is the Module 3 investigation 2. This investigation talking about the function relations and the domain of the function. So in the previous investigation, we wrote formulas to describe how the values of one quantity relate to the value of the another quantity. We said that the dependent quantity is a function of the independent of the quantity. If every value of the independent quantity produced exactly one value of the dependent quantity, in this investigation, we will introduce the uses, the benefits of the function notation, and then practice the representative formulas. So they assign each value of the independent quantity to exactly one value of the dependent quantity using the function notation. So we'll go to the number 2. But before that, we were looking at the box, okay? So in the box, so the formula for the function notation. So function notation, we use this, okay, f of x. So you can see the f or g or h and, whatever letter. And then the easier way is, you can just plug it in whatever x that is a given in here to plug it in right here, to right here, to right here. But this f of x is exactly the same as y though. That's a y. So when you have a plane, if there's an x-axis and y-axis, right? And then now instead of the y, we call the f of x. Alright, so the f represents the function of the input equal to the x that is input with the formulas we have. Alright, see number 2. Read above the formula with the function notation box, then answer the following questions. So using the function notation of the function name f, we define the box volume is f of x in terms of the length of the side of the square cutout x, as the formula of the f of x equal to x times 11 minus 2x times 8.5 minus 2x. So what is the independent input quantity in here? So in here, input quantity, which is about x. So the x is the, so input quantity is the x, right? The x. So x represented the length of the side of the cutout, the square. And then number 2, what does the f represent? The f is the name of function. So the f represents the relationship between the length of the side of square with the volume of the box. Okay, so what does f of x represent this time, right? So f represents the relationship between the length of the side of the square and then the volume of box, but f of x represents exactly the volume of box. And then what is the domain for this one? Do you remember the largest value for the input, which is going to be goes to half of the 8.5, because the 8.5 is a smaller size than the 11, right? So the domain, which is x, should be clearly equal to 0, but should be the half of 8.5, which is a 4.25. So in the B, illustrate each of the following the given graph of f. So the point 3.5 and f of 3.5, okay? So 3.5, I have to find it. So which is intervals about 0.5, right? So 3.5 is about here. And then which means this is place of 3.5 and then half of 3.5. So that's a point. What is a 1 point, f of 1.5 is? So 1.5 itself is right here, which means this is the volumes over here. So this is the volumes. So when you read it, it's going to be about 66, which is is it the feet per, no, I mean that's cubic inches, right? Cubic inches, right? And then what is the solution to f of x equal to 40? So 40 represents the volume, which means this is the 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 length of the side of the square. So which is you have to find the 40, which is the 40 is right here. So two places. So about here and then about here. Okay, so you got this place and this place is in here. So it's about x equal to 0 0.5 and x equal to about 2.9. Okay. All right, in C, use the function formula f of x equal to x times 11 minus 2x times 8.5 minus 2x to evaluate f of 2. Now you can just plug it in. So f of 2, now x is a 2, so 2 times up 11 minus 2 times 2 times 8.5 minus 2 times 2. So use a calculator, it comes out about the 63. So when you have a 2 right there, isn't it? The 2 right here, so about here. So this is about 63, okay? All right, so use the graph of part B in the solve for the f of x equal to 60 for x. Describe the solution of the value of the x represents. Okay, so you got 60, so 60 is about, 60 is about here, 60, right? It's about here. So this point and then this point. All right, so if you look at that, so x is about 1, or you can go further. Or there's another x, it's between the 2 and 2.5, so I want to say about 2.2. And then the E, the represent algebraically and on the given graph of the change in the box of the volume. So it should be the something f of x2 to the fx1, right? Two of different x value. As the length of the side of the square cutout increase from 2 inches to the 3.5. So becomes a 3.5 volume subtracted to f of 2. And then that will be the algebraic expressions. All right, so then let's go to the next problem, number 5. All right, in the number 5, we're going to talk about the vertical intercepts. The vertical intercept means same as y-intercept. So a function's vertical intercept is a function of the output value when x at 0 is the input of the value, the root of the f. So we also say that the value of f of 0 is always going to be the vertical intercept of f. So when you plug in 0 to get negative 2.5 means 0 and negative 2.5 is a vertical intercept. So at number 5, the function f function h defined by the h of x is 39 minus 6.5x. So this is a linear function which is give us a line. Represent the distance in meter that the torus is ahead of the hare in terms of the number of the second x. Since it starts at the 100-meter race, construct the graph of the h. Be sure to label the x's, okay? So label the x's in here. So x is a number of the second. So this is the time. So second. And then this is the meters. Okay, so 1 second, 2 second, 3 second for the horizontal axis, and then 5 meters, 10 meters, and 15 meters. So construct the graph means, I think I want to say the 0 second first. So h of 0. And then I got 39 minus 6.5 times 0, which give us 39. So I got 39 here. So about here. And then also, you can plug it in more number if you want. And then I want to say h of maybe about 4. You can put the 1 too if you want. So h of 4 means it's a 39 minus 6.5 times by 4, okay? Let's see it's properly used, okay? So 39 minus 6.5 times 4, which is I got 13, Okay, so which is when x is a 4, y is a 13, so about here, isn't it? And then if you connected it, 2 points, make a straight line. Oh, come on, I can't do. Okay, let me try it again. So make the straight line going through here. It's right here. Okay, give me the straight line. Okay, so this is a round line. Okay, so this is a line. All right, so yeah, that's straight line. So determine the vertical intercept h. So we need to find the vertical intercept. Vertical intercept is right here. This is the place. So vertical intercept means it's going to be the 0 and 39. Which means that the distance between the torus and the hera's when x equal to 0, which is 0 second, was a 39 meters. Okay, so when they're racing, right, the hair's right here and the torus already right here to run to this ways, which is the distance between the torus is already 39 meters away. Now, horizontal intercept. Horizontal intercept also called the zeros of the roots, which is we use a lot of the terms of the zero, which means the x-intercept. So anything the intercepting the x-axis, we call the x-intercept, and then we call the horizontal axis, or horizontal intercept. So horizontal intercept means y is always 0. Y is always 0. So we look for the x value to find it. So the given function h of x equal to x times x minus t 7, we determine the horizontal axis. So we just need to set the h of x equal to 0. And then solve for x. So x equal to 0 and x equal to 7. So let's do number 6. Continuing the same context from the question number 5, h of x equal to 39 minus 6.5x represent the distance in meters that the torus is ahead of the hare in terms of the number of the second x since the start of the 100-meter race. Solve the equation h of x equal to 0 for x. So h of x equal to 0 equal to 39 minus 6.5x. And then adding 6.5x both sides. Then I got 6.5x equal to 39 and divide by 6.5. And then I got x equal to 6. So which means when the 6 seconds, so what does that mean? So the x equal to 6 represent the number of the seconds since the race began when the distance between the torus and hales are equal to 0. So which is they met somehow, okay? But it's gonna be the after the finish, the one of the hare and the torus finish the race or before, okay? What is the root of h? So root of h means x-intercept, so which is x value, which is a 6. Which means if you represent as a point, it's going to be 6 and 0. Okay, all right, so there's a difference between the horizontal and the vertical intercepts. All right, let's go number 9. Without the using a graphing calculator, determine the domain and range of the function, following functions. So it's actually easy to find if you using graphing calculator, see, but they said do not use a graphing calculator. So let me fix the problem. So a should be 9 over x, and then g should be the 1 over x squared minus 9. Okay, the function a, which is s function, is a rational function. So when you see the x in denominator, okay, we have to be careful, okay, because x always denominator cannot be the 0. Because if you have a 0, you get the 9 over 0, which means undefined. So all real numbers are fine except the 0. So domain will be all real number, which is all real numbers fine except the 0. So not include the 0 means a parenthesis, 0 to infinity. For the range, since we cannot use a 0, so when you're having the y value, yeah, you won't get a 0 either this time. But sometimes you have a different number too, okay? And then g of x is also the rational function. Okay, so which means the denominator cannot be equal to 0, okay? And then so for x, okay? So you got x squared equal to 9, x equal to plus minus 3, right? So all the numbers fine except the 3 and negative 3, okay? So you gotta say domain is all real number except the 3 and negative 3. So this is how you write. For the range, okay, But this time, the 3 and -3 is not useful for the domain, but you will find every number except the 0. Okay, the C function is a linear function. Linear function means all the domain is available. The domain is a real number, which means the range you'll find every single y value from each of the x values. The k function has a two function is actually the combined. One function is the top function is a square root function. Then the whole thing is as the rational function. So two restriction we have to think about it. So which means inside of the square root always need to be positive, and denominator cannot be the 0. Okay, all right. So if you solve for x, add 2 both sides. So this is what it is. And then add 9 both sides. X cannot be a 9. So all the numbers find from the 2 except the 9. And then as a range, this time actually, even though we're gonna only use from the 2 to all the way to infinity except 9, which means you'll get all the y values too. Okay, number 10. Without using graph calculator, determine the domain and range for the following functions. So the p function is a linear function because x is on the top, which means we never get undefined case, which means the domain is a real number, which is every real number of the domain give us a real number for the range too. Okay, b function is a quadratic function, means x minus 4 always should be a positive. Otherwise, we get the imaginary number. So when you add 4 both sides, x should be greater or equal to 4. So as a domain, it should start from the 4 to infinity. And then because of that, you can only use from the 4. So you can have it from the 0 to infinity. All right, c function, actually the x minus 5 cancels out, so it comes out as an x, okay? So it looks like a linear function, but at the beginning this is a rational function still. So we cannot use a 5, okay? So as a domain, it's all real numbers except the 5. And then the range, because of 5, you can also find the 5 from the range. All right, what if you have a graph? The graph means is about even easier. So when you see, because that's why graphing is easier. Okay, so you have to see the coverage of the domains. This is a domain. Okay, and then graph actually the covers from here to up to here, isn't it? Do you see that? Do you see the graph over here? So it covers. Okay, so domain is. It covers from the -4 to up to -1. And also there's a coverage over here too, right? And there's also the coverage right here. So this coverage from the looks like a -0.5 to 0.5. And another interval which is from here to up to here, isn't it? So 1 and 3. So domain is gonna be the 1 and 3. And for the range, now you have to look at the y-axis. So y-axis give us the ranges. So this is the range of the y. So as you notice, range is, okay, starting from the lowest number is -3.5. So -3.5. And then, and that's just the point by itself. And then it starts from the here, which is -1.5, up to the 0, isn't it? Do you see there's a graph between? So I want to say from the -1.5 to up to 0. And then you'll see that the graph starts from the 2, right? And then up to the 6, okay? So you can say from 2 to 6. All right, so that's that is the range for the graph. Okay, so if you have a graph, easier to find. Okay, thank you for listening.